Okay, try some new technology out here today. So I have a piece of paper and I'm going to write on it. So let's talk a little bit why we do so. So we've talked about a little bit about limits and let's talk about some specific type of things. So if we take a look at a simple function, how about we go f of x is equal to 2x plus 4. And I ask you, find the limit as x approaches 3. So pretty straightforward. There's no discontinuities here. There's no really issue. We can find the limit through straight substitution. And through straight substitution, we just plug it in. 2 times 3 plus 4 is equal to 10. So the limit of f of x as x approaches 3, f of x approaches 10. And we're done, straight substitution. So if we want to go a little farther than that, move my piece of paper up a little bit and get my little more work time. So now what we looked at the other day is what happens if it has a discontinuity in it. So a for example would look like this. If f of x is equal to x plus 1 times x minus 1 all over x minus 1, and we want the limit as x approaches 1. Well, if we put in 1 in the top, we get 2 times 0 over 0, which is equal to 0 over 0, and this is called indeterminate form. All right, so indeterminate form generally means that a limit does exist, but you have to do some mathematics to figure it out. In this case, it's simple factoring. So we know that there's some sister function, okay, that if we cancel out the x minus 1s, all we're left with is f, and I'm going to, I don't know, make up my own notation, f sister of x, don't look for that in any books, you won't see it, is equal to just the function x plus 1. All right, so this graph of x plus 1 just looks simple like this. Plus 1 would be our y-intercept. Our slope is 1. It would look like this. So the sister function x plus 1 looks like this. So you ask yourself, how could I find the limit as x approaches 1? Well, I just simple substitution in, and that's 1 plus 1, or 2. So the limit of our original function as x approaches 1, and for that matter, the limit of our sister function as x approaches 1 is 2. So what that means is that x is equal to 1, the value is 2 up here. Now let's talk about this. This is the graph of the sister function. However, if I wanted to graph this original function here, the main concept is there's a hole that exists in this graph right here, and that exists at the point 1, 2. So the sister function here, x plus 1, straight linear, does not have a hole in the graph. The rational function, x minus 1 times x plus 1 all over x minus 1, does have a hole in the graph. They both have a limit. The limit of f of x as x approaches 1 is equal to, or it tends to, we say, 2. And we use that one through factoring, and we were able to find a little sister function and still plug it in. Basic concepts, I'll show you some more when I look at definition in another video, but the basic concepts is if the y value approaches the same exact y value from the left as it does from the right, and in this case it approaches the y value of 2, then a limit exists. It does not matter that there's a hole in the graph, and in the original function, this point right here is actually 1, undefined, because it is division by 0 happening here. In the sister function, it's 1, 2. In the original function, it's 1, undefined. And that's probably enough for this video. Thanks.